the videos. Oh, okay, then never mind. Don't worry about it. Don't worry about it. Well, we have a presenter. We have a presenters on the west coast of the U.S. up after midnight, so I don't want to delay getting started. Go. I can run this. Okay. Okay. So as I mentioned, we're going to get started on time today because our first presenter is on the west coast of the U.S. and has very nicely agreed to present in the middle of the night for her. So let's get started. This is the Information-Centric Networking Research Group. We've been going for 12 years now. So this should be a familiar group of people for everybody. And I'm going to run through the mandatory slides very, very quickly. You've seen them many times before. If you agree to be here, you have to agree to the intellectual property rules of the IRTF and the IETF. Remember, we are doing audio and video recordings of the meeting. So just by being here and logging in through MeetEcho, you are agreeing to being captured potentially on audio and video recordings. We have for the both the IETF and the IRTF, a privacy and codes of conduct. One thing I'll quickly point out, which is new, is that the IRTF has adopted its own additional code of conduct, which goes into some things that are a little different from the IETF because we are an academically and research-oriented rather than engineering-oriented organization, and hence some of the things about academic code of conduct go beyond what is specified for the IETF. So we are in the IRTF. The goals are to promote research in internet technologies. We are not a standard setting body, which we are a body that promotes research in internet technologies. So some meeting tips, make sure that you're signed in, please, through MeetEcho. Keep your audio and video off during it. If you're using the full client, if you're using the on-site version, we prefer that you do that if possible. And for remote participants, make sure your audio and video are off unless you are presenting during the session. Okay. So our general administrative stuff, you can look on this slide. You can find the mailing list, the web pages. Dirk Kutcher and I are the chairs. Dirk was here a moment ago, but Dirk will not be continuing as chair because he is now chair of the IRTF. And if there's interest in the community of someone who would like to take on a co-chair role, please talk to me and Dirk. We have our note taker. Thank you very much, Marie-Josée, for agreeing to take notes. You've been our note taker multiple times over a number of years. And hence, we really like to thank you for your service over a very long period of time. There are a number of meetings that really could not have gotten started in an expeditious way without your help. So our agenda, we have 3 talks and a quick update on one of our drafts towards the end of the meeting. So to keep right on time, unless there are any questions, I'm going to go straight into our presentations. Just to note, we have a number of active drafts that need further review, and please take a look on our documents page in order to find those and keep up to date on what's moving forward through our own progression of documents in the research group. So let's get the presentations going. Hang on. Stop sharing. Whoa, stop sharing. I need to stop sharing. How do I stop? I need to stop sharing. There we go. All right. Kathleen, good morning. You're on.
Okay.
Would you like to share the slides yourself? That makes it easier.
So I think I request slides and then.
Yes. And then I approve.
Okay.
And you have control of the slides. And again, in advance, thank you so much for agreeing to do this in the middle of the night.
Well. Okay. And I'm not quite sure how do I, oh, I see it's down here. Okay. Shall I start? So I'm hearing a lot of echo. Is that me or?
I think it's you because we can hear you just fine.
Okay, I'll just try to ignore it then. So the reason I'm talking about this, even though the information or data-centric structure I use is kind of different from CCN and NDN, is that when I was doing this, I found myself spending a lot of time thinking about the properties of things that are information-centric and how that's really different from things that are endpoint-centric, and how I could take advantage of them and needed to take advantage of them. And I think there's something there that is good for everybody to think about, because sometimes we don't move ourselves into that domain enough, I think. So here's my problem. It was clock synchronization over a limited domain. And the framework I use is Define Trust, and it's a information-centric framework, and it is specifically for limited domains and has its own transport at the Define Trust transport called DEFT that runs over IP. And we're using limited domains that are kind of focused on operational technology and critical infrastructure networking. And it works by having a publish subscribe API into collections of publications. And these publications are time-stamped. And this is a critical part of the framework. That one of the reasons is to help prevent replay attacks, and another is so that you can expire things. You can imagine that if you never expire anything, the collection is just going to grow without bounds, and that makes it a lot more difficult to synchronize. So what's happened is we were using this and things were working fine. And then in a particular deployment, Scott Gray from Operant Networks found that he had devices that did not use NTP, and they didn't want to. They did not want to connect to the internet because they figured that could be a security risk. So our timestamps allow for skew and transit delay. We could even be up to half a second, but it turned out that some of these devices had clocks that are off by hours, and that could be a real problem. Even something like 10 minutes. We ran into some sort of weird things where the certificates are all valid, but then when you go try to communicate, nothing works because things are on different clocks. So the solution was to give DEFT its own integrated self-contained virtual clock that is calibrated according to its needs. There we go. So just a little bit more context, so that the most important part of that I want to get across is the idea that we're working within a limited domain, and it's a defined trust limited domain, but I just call it a trust domain or a TD, and that's what I'll be using going forward. And some of the other particulars here aren't necessarily important for what I'm talking about today. So I've got it here in the slide. You can read it if you want to, but I'm going to move on to show a picture of what I mean here, which is, this is a picture up here of a trust domain, and it can span a lot of subnets, and those subnets are interconnected by these relay devices with ours on them. And it's possible that not all of the devices in a subnet could hear each other directly. This one up in the upper right, for example, maybe doesn't hear the ones that are over closer to the relay. But the way that things normally work is that the members that it does hear can get publications to it by wrapping it up in their own um, CAD PDUs and passing them on. And that's part of the synchronization process. And again, I just want to emphasize that our communication models between all of these members and the collection of information, not which is in the form of publications and not between endpoints. So there's a lot of ways to calibrate clocks in a network, and the internet-based approaches are usually accessing globally accurate time servers. So that gets you a really good clock, and it's important to be close to a global time source. And I looked up a lot of sensor network approaches because I thought that might be promising for us, but they seem to designate or elect the sort of primary sources for clocks, and then they'll build trees to distribute this reference time. And they estimate the skew and the offset parameters at each one of their member devices relative to the reference. But this sort of a setup, neither one of these are attractive to us. The one connecting to the internet isn't good, and the other is kind of this idea of building trees, is a kind of planar sort of idea, and you're communicating between endpoints and passing the data along. But we wanted something that would be self-contained and also really failure tolerant, and not just actual failures, but things going to sleep and coming back online. And in that case, if you've got something like a tree and something goes away, you're constantly having to rebuild your tree. So we needed a different way to do this. But but we can approach it somewhat differently because of some of the characteristics we have. We're only using this virtual clock for the publications, and it's implemented as an offset to your local clock. And you just use your own, as a member, it uses its own system clock for timers and things. And we don't really need to track actual time, and we don't need to be monotonic over our history. I mean, obviously, it gets to be a problem if you're going back and forth a lot, but within the time span of most of our publications, it's fine. And our relative precision of our clock could be as large as that half a second, but we're aiming for better than that. And then the other decision that I made was to ignore the skew estimation because we're working in an environment with collections, and we're publishing and subscribing to those collections. So we're sort of, in a sense, we can always keep track of things. And what you just do is periodically publish your clock value. And then anyone who hears that will realize when they've drifted out of tolerance and go back into a calibration state. So what you can just do is keep adjusting your offset. You don't have to do some guesswork and estimation of skew, which actually turns out to be pretty difficult. People can do it and do the math, but actually making that work in the real world can be sort of difficult sometimes. But we're always free to borrow from other approaches while meeting our needs. So I certainly always feel free to do that. So back to the picture again, and I've got sort of a little summary of the things I already said. And but our approach is to be completely distributed between the members, no external servers, and our time domain virtual clock calibration is only within single hop reachable neighborhoods. So all of those dotted circles, or I guess ovals up here, are representing neighborhoods, things that can be reached in a single hop. And then we propagate the data like sort of gossip or diffusion style. In order to do this, we have to use sort of non-default sync parameters. Uh, so one of these neighborhoods could be smaller than a subnet. You can kind of see that up at the top. And also, in this case, the way we set our sync module is so that it does not send pubs of others. So we sort of turn that ability off, or tell it not to do that. And we also have really short lifetimes on our clock pubs because we don't want to republish our own, which is something we would typically do if somebody didn't get it the first time. That's part of synchronization. But we don't want to do that because that's going to introduce some error into the clock, right? Because of the extra delay. So those things are actually pretty easy to do. And again, it's nice to take advantage of these properties of our type of a network, right? And also the thing with the neighborhood is it fits the kind of meshy networks that we want to have better. It can be more fault tolerant. We don't really care if things come and go. For example, in this picture, I don't know if you can see my cursor or not, but if we look at the sort of I don't know, purplish member there that's in two neighborhoods, if that goes away, you've disconnected the domain, but both sides can just happily go along and synchronize among themselves. And if it comes back online, they'll be able to be completely, anything that they've gone apart, they'll come back together again. So back to that notion that we've got collection-based communications where the collections hold the pubs. And normally we have two of collections that are required: the messages collection because it carries application data, and the cert collection because it has certificates, and we have to have those for our identity. And it's optional to have a keys collection, but you must have it if you're doing encryption. And I've kind of shaded these two that I'm talking about in this talk. One is the TDVC collection for coordinating the virtual clock. And I'm hoping I'll sort of mention this logs collection that I use to get some information out for plotting. And the trust domain virtual clock, it's implemented as a distributor that uses that TDVC collection. Right. So now on the left-hand side, I've got a little bit of a diagram of how the calibration works. So at every member, oh, that's strange. The thing in the blue doesn't show up, but it up here, the top one should say state 0, and the middle one should be states 2 through 255, and the bottom one should be state 1. But I don't know. It disappeared somewhere along the line. It was in my PDF, but anyway, so the top one, when you're in your calibrated state, you're in state 0, and you're going to just publish your clock periodically, approximately every 10 minutes. And that looks like this over here on the right-hand side. The publication that's contained in this CAD looks like this. It's got the first two components are the first one's just the prefix we use for the domain. We don't actually have to have it. It's just something we got in the habit of using so that when you're looking at the hubs and packet dumps, you kind of can see clearly what's going on. The second one is the subtopic for the calibration. So it says this is a clock publication. Then this next field is what state we're in. We're in state 0. And the next field is the number of neighbors in my neighborhood that are in agreement with this virtual clock. If you're in state 0, it should be equal to all of the neighbors that you hear from. This next component is, again, it's kind of optional. It's the publisher's name tag. And that's, again, something so that when I'm looking at a packet dump, I can sort of see that quickly. But an actual member, an actual deft will pull the identity out of the signing chain. Okay, and then here's a second one that is published by a different member. So you're going to sit there until or unless you get a value from somebody else that has a state that's greater than or equal to 2, or if the difference between your virtual clock and the timestamp in the received publication exceeds your tolerance. And we can look at that. So with these two, what's happening is that now a timestamp difference pops up that was greater than 30 milliseconds, which we set at a tolerance. So that's what gate computes. So that causes gate to turn around and move into the computing offset state. And it always starts with its state set to 2. And that is what its publication looks like. So in that computing offsets state, it's going to publish a set of clock values. And right now for me, a set is 3 values. And what it will do is it will take its timestamp, and the timestamp that it puts in those publications, it ends up being the virtual clock plus an adjustment, which starts out as 0. And then it's going to process all the received values that it gets from everyone else as a difference from its local clock. And at the end, it's going to go through and find the statistical mode, and it will update its adjustment to match that mode. There's some other stuff that goes on, but it doesn't really matter. So it's going to sit there, and if it doesn't have all the neighbors have essentially 0 difference, it's going to bump its state up and do this over again. But once all of the neighbors are essentially 0 difference from each other, it's going to go into this pending state, which is state 1. And it has to spend at least, I put it down as count here, number of rounds in that state. And I've set that usually between 4 and 6, but 4 seems to be working pretty well. And you don't want it to be too long because you're adding a lot of redundancy time that you're sitting there. But the reason it's there is for more complicated kinds of networks where things are happening, in one part, and then by the time something gets through, we don't want to keep thinking that we're done and start over again. So that's partly to keep that from happening. So if you're sitting in that state and you happen to receive another value that's out of tolerance, or you receive a publication that shows you that one of your neighbors is calibrating because it has a state of 2 or greater, you're going to go back to the computing offset state. Otherwise, you're going to sit here until all of your neighbors are in state 0. Actually, this shouldn't say or 1. It should be all neighbors in state 0. And once that happens, oh no, that's right, 0 or 1, sorry. It's late. And so then you're going to take your virtual clock, you're going to add that adjustment to it, and then you're going to go back into that state where you just sit there. And this is really just words of the same thing. But this is a packet dump of what's going on. And you can see here's what this is a timestamp of the capture timestamp. And the second field tells you whether this is a state or an ad. And I'm looking at the shaded value, the ad that's being done by side door, and it's in the TDVC collection. So you can tell all those things on the first line. And the second line below it is the publication that that PDU contains. And we saw that on the previous slide. And it's these two publications that started that calibration. And but now you can kind of see, if you look down below, you can see all the other members that dumped out their publication that has a 2 in their state, which says, okay, they're going to start calibrating. And there's 3 of these clock publications by each member in each round. So this kind of goes on for a while. So I started just showing the publication part along with the capture time instead of the outer PDU wrapper. And you can see here's a few more that are published, and then we move on to another state where, and now you're in a state where some of them are in state 3, and you can see a couple of them have 4 neighbors that agree with them, but another one only has 2 neighbors that agree with it. But this goes on, eventually everybody agrees, and this is what you should see at the end of which is everybody's in state 0, and we get this, and that's great. But it's really informative to look at these packet captures, but you have to kind of go line by line, and it's hard to get a sense of what all is going on. So I got a little bit better sense of watching the calibration happen by taking the state value out of the publication and then plotting it against time. So now what's happening here is if you look at this shaded thing, you can see where side door state 0 value kind of kicked off the calibration. It was 0, and then everybody else kind of went up, and there were all those 2s, right? Some of them overlap. And then there's some that are in state 3, some go up to state 4, but some drop down to 1. And now there's this long period of time where everybody's publishing, everybody's in agreement, but they have to do it enough times before they could go back down to state 0. So that's the entire calibration. I was processing some logs publications, and what I'm doing with the logs for this run was whenever you change your adjustment to your clock, you publish a log message. And in this case, backdoor didn't change, so it's not on this list. But what I did was kind of process those publications where the first column is that capture time, and the second one is that time minus the timestamp that was in the log publication. And you can see that they nicely came out to be within 5 milliseconds. And that is the quantization that I used here. So that was great. So, but there's a practical issue, right? That we have processing and transit delays, and those are always going to add noise to our clock values. And one thing that I do is quantize the differences, and I'm always rounding down. And that quantization should be at least a little bit greater than the expected transit processing delay for the particular subnet. So in order to keep an eye on this, I've included a round trip delay estimator in the distributor, and it also kind of works in the neighborhood. So for a broadcast subnet, that estimate is really nice to use as a quantization. If you've got more significant delay, it might be possible to subtract that from the clock differences before you use them. but this is something we're going to explore some more in the future. And within that, the round trip delay estimator, you're always taking samples, and the older samples are discarded, and you use the minimum values so that you factor out as much noise as possible. And then the idea is that if the delay estimates show some significant change, you can change your quantization. So this is what's happening there. We send a ping. I've been doing it on the order of 10 minutes, but it could be much longer, right? Because this is something we expect to be kind of stable. And you just randomly select one of the members that you've already heard from, you, and by its the thumbprint of its identity cert, and you save that, and you save the current time, and you publish the ping, and it looks like this. Similarly, it has a prefix for the domain. The subtopic is PNG for ping. And this is the next component. It's the thumbprint of the identity cert of the desired destination. And then again, this is the name tag and the timestamp. So what happens is if you receive one of these and it's not your thumbprint in that third component, you just save that at the current time. And otherwise, if you receive one and it's your thumbprint, so here this is the ID thumbprint of front door, then you publish an echo, and that's what that looks like. But when you receive one of these echoes, you use the signing chain to get the publisher's thumbprint. You retrieve that earlier saved time, subtract it from now, and save it on your round trip delay list. And you can keep that list per neighborhood or per sender, depending on whether there's some weirdness going on in your network. So you want to keep it, by sender if delays are really different. But these more passive ones, they would be smaller because of, you're pulling it off of the network, but so far these times are negligible, but that's something else we should keep an eye on. Okay, so here's early testing results. So I tried having like 8 members, but I emulated the network on a single machine where the round trip delays were less than 2 milliseconds, and I'm using 5 milliseconds of quantization and 30 milliseconds of a difference tolerance. And I've tried different things. You can actually use huge offsets, and it doesn't really make that much difference. You resolve it really quickly. But then what I wanted to do is have a kind of randomized drift emulation. And I did it this way by just adding a 5 millisecond and then a random number between -2 and 2 times that 5 milliseconds, and adding it to the clock at 2.5-second intervals. And there's 3 types of connectivity that we can emulate: a fully connected one, 2 overlapping groups, and kind of a linear arrangement where you only hear 1 or 2 of your neighbors. And the calibration times, it took like 2.8 seconds for both the fully connected and 2 group one, and 8 seconds, as you could imagine, for the linear arrangement, because everybody's going to kind of restart. And I'll show what that looks like. So the values I plotted were, I got a little bit smarter, and I published log messages when you first enter that state 2, the calibration start, and also when you first enter state 0, because you're finished. And what you're doing is you're pulling out the timestamp of those. And here you can see what it looks like. It's got it's in a CAD for the logs collection, and it indicates what it is. It's a TDVC calibration message. And then we can just take the difference of that timestamp from the capture time and use that as an estimate of the offset value that was used at that member. And I mean, it's going to be off a little bit. And then we also can extract the state from the clock publications like I showed you earlier. Okay. So here's 8 members that are fully connected. And, here, the sort of weird pattern here is because this is the point where somebody publishes their clock and then they go through calibration. And if you look, this is showing you where it was when it left. So you can see that they're much closer together, right? And that keeps happening. This kind of weird behavior is probably because somebody's drift emulation went off while things were still kind of unsettled. So it kind of changed clocks in the middle of a calibration cycle. If you look here, I decided to kind of blow up what was going on so you can kind of see. So here the clock drift triggered a calibration, and then what happens is the calibration went on, and then there's more publication here. In some cases, they restarted before they finished the calibration. It's not necessarily drift emulation that'll cause the restart. It could just be that they thought they were converging, but they went into state 1, but then somebody sent them a state 2. But we get here, and this is where everybody's close to each other. So this is a final clock. I guess you can't quite tell on here, but they are all quite close. And because I can look at command line output, they actually all had the same offsets for real. And this one, this one's not so interesting. It's just these two, and at the different times, they calibrate and try to come back together again. So I like this one. It's kind of interesting, right? Because you can only hear your neighbors. And just looking at this part, you can kind of see there's a little bit more weirdness happening. And you can definitely see the weirdness when you look at the state in the clock publications. They're getting much bigger states. That means a lot more rounds to be calibrated than the other ones that I showed you. And this one goes up to like 14, and here we're up to like 34 rounds. But we get calibrated, then we go back into just sending out these periodic. Uh, Here's my clock. I think of them as probes, and these peaks, right, correspond to the calibration cycles. Okay, now I wanted to go try this in some relayed trust domains. And just a quick note that relays connect different subnets. So they'll have at least 2 defs. They could be in different domains, and they're moving the publications between them. And the way that I make this work is that the relays act like a single node in the virtual clock distribution. So when they're hearing, these, they feel like each of these subnets is in their neighborhood. So this little example has us connecting these 2 sides through a TCP link that connects 2 relays. And I started up the right-hand side members and their relay first, and then the other side. So this is the startup, and there's a 5 milliseconds difference range after calibration. You can kind of see the dots here. The initial numbers are like off the scale, but that's not particularly interesting, and it makes it hard to see what's going on. So there, and now here again, we came in with these different values, but we leave with 3.5 milliseconds of range difference. Over here, it's a little bit bigger, it's 7.6, but again, that's includes sending time. And then here's the corresponding values of the calibration state. So it's interesting that it doesn't have to, go up to really high number of rounds in order to get through. And this is a detail of the startup. Here's the right-hand side starts. There's the members, that's the relay, and boom, there they all are in the pending state, and there they're calibrated. But then the left-hand side starts, and everybody has to start calibrating again. And okay. And yes, I can do that. So the next steps for the distributor are larger scale testing is going to be coordinated by operant networks. And there's a lot of things that we want to test, obviously, and iterate the algorithm if needed. And then the next thing I want to say before I get the boot here is that one of my pet things here is to think about what's going on, and I'm always trying to answer that question when I work on this stuff. And this is another thing I think is sort of universal to information-centric networking, that it sort of changes and challenges our perspective, and we're not monitoring connection state between two parties or two endpoints. We've now got communications that are between endpoints and the data they're looking for, and it's all over the place. Everything's distributed and there's multiple parties. So how do we track this? And i I think that um, the diagnostic tools in this area could really use some work and some thought, and I don't feel like I've really seen enough of that. So I'm really think that it would be nice if we all kind of opened our minds to different ways of thinking about things, because we're used to, that sort of plainer way of thinking about who's talking to whom. The basic things I use is this thing called DCT Watch. It's sort of a TCP dump for Deft, and I've now been using a logs distributor, taking advantage of pub sub. But these are pretty basic things, and then you still want to be able to know what's going on. One of the things that I've looked at that I think is kind of cool is a tool from distributed systems, but it won't scale very well, but it seems like you could take something like this TS-Viz and make it scale. So that was the last thing I wanted to say, because um, I feel like I always want to make this pitch that we need to think about better ways to figure out what's going on when we're not just talking between endpoints. Okay, I'm done.
Super. Thank you, Kathy. We have questions? Just add yourself to the queue. I'm going to ask one question, which wasn't clear. When you do these clock adjustments, obviously that synchronizes the virtual clocks. How do you back propagate that onto the system clock of each device? Or you don't bother to do that, and the applications are expected to not look at the system clock and only look at this virtual clock?
Yeah, okay, so the virtual clock is used for publication timestamps and things that are related to them. Yet you use your system clock for everything else. So if I'm setting a timer, I'm going to use the system clock. But if I'm um, looking at the publication arrives, and I want to say, has this publication expired yet? I'm going to look at my virtual clock. But because when publications arrive, we sort of compute when they expire and, and dump them into our local collection, it's okay if the clock even changes while they're there, they'll still expire at the same time.
Great, thanks. David?
Yeah, I had a number of questions regarding the results of the synchronization process. So first I was wondering, you're talking about setting a quantization of the clock adjustments that you make that is larger than the round trip time.
Yeah, well, yes, right. But in broadcast type networks, yes.
What happens if you don't do that? Does the stuff become unstable, or is there sort of some internal emergent property of the way you're synchronizing the clocks that makes you correct essentially for the transmission delays?
So I think if if you think you're in a case where things are going to be more, I did a little experimentation with this early, but nothing later. So what I think is if you're in a place where, you're not really very sure of it and you've kind of underestimated it, you probably should have set your tolerance to be larger. So like you want you're not going to be able to calibrate your clock quite as closely to the whatever the quantization is. So I could still use a quantization of 5 milliseconds, but I should be using a tolerance that's larger than that because there's a lot more noise in my measurements.
Okay, but things do remain, if I understand you correctly, things do tend to remain stable even if the transmission delay is larger than your quantization time.
It seems to. I can't say I've done enough experimentation yet, but I'm kind of looking forward to us having a larger test bed, and because building test beds is a lot of work, I decided to wait until somebody else would do that, and then work on the experiments with them. So. But that will be one of the things to look into for sure. But at least in initial work that I did, it seemed to be okay.
Is there time for more questions?
Quickly, because we need to keep going.
Then the second thing that I wanted to ask about is what kind of quality of clock crystals for the system clock you need to keep this working stably? And at what point do things become too unstable to synchronize?
Yeah, well, I think if it's changing and a lot, like I said, what we were sort of figuring is that most things out there, I don't know, I put the numbers in the slides, but it seemed like the worst case of most of the kinds of things we would encounter would be that we would be drifting like within 12 seconds or so. So it seemed like that would be okay. But I guess if you've got a clock that's just really all over the place, then which that was not our problem. Our problem was more just that things were not synchronized.
Okay. Thank you.
Great. Thank you. Kathy, thank you so much for
Fine.
staying up late. To see you
Now I'm awake.
Hope to see you in the flesh sometime.
Okay, thank you, Dave.
Great. So our next speaker is Yusako Hayamisu, who will give us a talk on ICN for cybernetic avatar and metaverse. Let me give you the slide clicker. There we go.
So, thank you for introduction. I'm Yusaku Hayamisu from NCT Japan. Today, I'd like to explain the ICN for cybernetic avatar and metaverse. So this is outline of today's my talk. First, I will explain the research background, and I introduces some use cases. The one is the cybernetic avatar CA and the metaverse in the XR and the AR context. So we are now developing the CEFO, which is a CCNX 1.0 compliant software implementation, and it can be used for the realizing these use cases as applications. And I also introduced our research activities in the ITUT study group 13.
Is it not working?
Where is it?
It's weird. Let's try this. Try it now. There we
Okay,
go.
thank you. So background, the metaverse imposes a stringent network requirements such as high bandwidth and low latency and stable jitter. In real-time video delivery, such for over the full HD, such as a 4K and 8K, and less than 200 milliseconds latencies are required as studied in the following literature. So we believe that ICN natively supports the in-network caching and multicasting and multipass communications and name-based state of forwarding. So we believe that ICN can provide efficient communications for the metaverse applications. So we are now have been working on the following two projects. One is the cybernetic avatar CA applications by the JST Moonshot project, Goal 1. The JST is a national government of Japan. In the CA applications, sharing teleoperation for the multiple avatar robots should be realized. So we are trying to realize the M2N bidirectional communications. In this case, the M means the number of the teleoperators, and the N means the number of the CAs. So we are trying to realize this in this project. Another project, XR-based remote experiment, which is funded by the NICT internal project. And in this project, researcher remotely conduct physical experiments by controlling the lab equipments. So we are now introducing some use cases, the CA and the metaverse. So first, I would like to explain the CEFO. CEFO is a CCNX 1.0 compliant software, which is developed by the NICT, and it is now open in the following GitHub. And CEFO has a design principles for the following three design policies: lightweight for the resource constrained devices, and also try to provide a usability for the configurations, and also extensibility by using the plugin software for the accommodating the novel functions. So we are using this software as a network platform. The first use case is sharing teleoperation for the CA robots. In this case, the in this means M means N. The two teleoperators manipulate the 4 CA as shown in this figure. So in this case, M to N means 2 to 4 sharing teleoperations. And the teleoperator 1, in this case, sends an interest packet for actuating the action of the CA robots. In this case, group 1 CA here and here, after receiving the interest packet, they'll move to right. And then another interest, for example, take a photo actions. After receiving the interest packet, CA taking a photo, which is one use cases. And also, we are trying to realize the bidirectional communications by using the reflexive forwarding specified in the following ID. So in this case, the data update always action data will be forwarded to the CA or the CS, and it will be updated. So we believe that reflexive forwarding can be the key technologies enabling the bidirectional some communications between the CA and the TO. And the next use case is XR applications for the remote experiments. In these scenarios, Kobe and Tokyo remote experiments. So actually, this is ongoing work and presented in the IEEE Metacom, Metaverse Computing and Communications Conference in the next August in Seoul. So the Tokyo site can be the Seoul in this example. So in this scenario, XR user wearing a headset like here in Tokyo touches a virtual object like this for controlling the remote equipment, lab equipment configured in the Kobe area. In the Kobe area, there is many lab equipments such as quantum emitter microscopy and also the robot arm those for manipulating the lab equipments. So as the video stream delivery, we are trying to use this communication. And we newly developed the consumer and the producer applications which running on the usual iPads. So we can see the clear feedback from the producer side to the consumer via CCNX multicasting. Unfortunately, I prepared a video, but it cannot be shown in this presentation. So, okay, it's one use case, another use case is for the remote experiments. And the next, I just introduced some activities in the ITUT study group 13. So we submitted the draft recommendation in the ITUT SG 13 Y-point ICM CAM. The title is Information-Centric Networking Enhancement for Supporting the Cybernetic Avatars and Metaverse Services. So this draft aiming to specify the requirements and the architecture framework of the ICN for the CA and the Metaverse services. And we trying to proposing and discussing the applicability of the ICN to supporting the CA and the Metaverse services. But this is a very preliminary and working progress documents, and we are now trying to discuss which content should be here and presented in this ICNRG. So yeah, this is just information for yours. Okay, I just summarize my talk. We explained some ICN architecture for the CA and the Metaverse, and we introduced some use cases, the CA, cybernetic avatar applications, and the XR-based remote experiment by using our developing software, CEFOR. And we just introduced some standardization activity in ITU. Okay, so this is my end of talk. Thank you for your kind attention.
Lovely. Any questions? This is a very cool application. So
Thank you.
great. I put one suggestion in the chat. You can look at it later.
Okay, I'll see it later.
Anybody going once, going twice? Lovely. Thank you, Yosaku-san.
Thank you.
Come on, stop sharing. Here we go. Danielle is here. Hi. Nice to meet you.
Yeah, nice to meet you as well.
Let me get these slides up for you. So just a little background for everybody. Dirk and Daniel got together and you gave this talk at another one of the working groups, and it seemed like there was actually a lot of stuff here that the ICN community could learn from. So
Yep.
that's why we invited you to come and give this talk. So give me a second. Get right up and then pass you the clicker. You have the clicker?
Yep.
Okay, great. That should do it.
Sweet.
Great, thank you.
Everybody hear me okay? Sweet. So my name is Daniel Holmgren. I work at Blue Sky. We're developing a protocol for decentralized social media networking, as well as a microblogging application built on top of that protocol. And yeah, I met Dirk, or actually I met Dirk before that, but we got to talking at a side meeting that we had on Tuesday and noticed some overlap between what we were doing and ICN. So real quick before we start, I guess I said that first part already. We're strongly considering bringing parts of the protocol to the IETF. That's what that side meeting was about on Tuesday. So if you're interested, keep an eye out on the mailing list and for some drafts coming online. For people that are aware of Blue Sky, quickly clear up some misconceptions. Jack Dorsey and Twitter are not involved in the project. It's not a blockchain. There's not a blockchain anywhere near it. AppProto is not just for microblogging. It's a generic protocol for publishing social data or structured data. And then we have written specifications as well as a dual licensed MIT and Apache 2.0 reference implementation. You can check those out on our GitHub and at proto.com. So real quick to contrast it with ActivityPub, which is another decentralized social networking protocol out of the W3C. And I think that this will kind of give a flavor for AppProto. AppProto is really based around decentralized publishing, kind of making something available in a generic way on the internet, whereas ActivityPub has this federated architecture and passes messages back and forth between nodes in the network. AppProto is built with the goal of having global, big world social, being able to replicate the experience of global social networks such as Twitter, whereas ActivityPub is really based around interconnected communities. Your location in the network strongly influences your experience of the network. Everything on AppProto is manifestly public, totally out there, permissionless, anybody can access it. The social vocabulary is not built into the data transfer spec at all, or into like how the messages are constructed. It's encoded in a schema system on top of that generic data transfer mechanism. And then I really think that kind of what characterizes AppProto is maybe it's like history or the movements that it comes out of, which is much more of this like peer-to-peer, content addressed, putting stuff in Merkle DAGs, Merkle trees, and transferring those around the network. Whereas ActivityPub kind of has a history in RSS, WebFinger, JSON LD, W3C type technologies like that. So to characterize AppProto a little bit, data is all signed, location independent, self-certifying data. That means that the signature is included with the data. That allows for it to be rebroadcast around the network, received from many hosts. You can receive your data from any location that you like, check the signature and verify that it's authentic. What this lets us do is root authority in the user identity as opposed to rooting it in the location that you receive the data from. The other thing is that we can split this generic data hosting that makes this data available from the application layer semantics that run on top of it. So users will host their data in kind of generic personal data servers or generic hosts. They keep their data online, make it available. It gets rerouted throughout the network. That data is addressed off of the user's identity, and then servers will compile that data and provide views on top of that data, kind of imbue it with the application semantics. And then AppProto, in order to gain these benefits of being a decentralized network, we really prioritize credible exit over having just a trustless or flat, totally flat network architecture. And so, yeah, it's sort of characterized by any service in the network is able to be switched out for another server that fulfills the same function. A lot of this comes out of the user repository. In many ways, this is analogous to a Git repository. It's a signed Merkle DAG that can be redistributed around. It's actually a Merkle search tree. There's a link there to the research paper that describes the Merkle search tree. As I said, these repositories are canonically hosted on a user's PDS. They just contain a bunch of structured records. Those records can really be anything you like. It's a CBOR object, often presented as JSON. It might be a post, it might be a like, it might be a follow, it might be your profile. Any sort of social data or structured data that you like goes in these repositories. They're sorted into collections, so they have a little bit of a hierarchy inside of the repository. And updates are synced out over a WebSocket stream of essentially deltas to the repository. You get some benefits to having all of the data in the same repository. For instance, positive proofs of deletion of data, as well as you can reliably prove that you have every single piece of content from a given repository, that you haven't missed any updates. And yeah, I think that this might be the thing that most closely links this to ICN is looking at the addressing scheme for this data. So these are AT URIs, how we address data in the network. You can see the top one is a URI to one of my posts. It has a DNS name in there, but whenever you, we use a bidirectional linking scheme to link DNS names to decentralized identifiers, which are essentially a global UUID for users. And whenever you dereference that DNS name, you get this decentralized identifier. It's a totally location unaware identifier for this piece of content. It can be routed to a canonical location, but you can also get it from other locations throughout the network. And we sort of pun on the authority in a URI to say that the authority for this piece of content is not the location that you're receiving this piece of data from, but rather the authority is the user that's generating it, and therefore the signature that they put on that data. This is sort of our @proto stack. I use stack loosely. These aren't actually all stacked on each other. And I won't go through all of these, but I will just kind of call out that broadly there are three parts of @proto. There's the data and sync component, which I've spent most of the time here talking on. We also have an identity and authorization component. We use decentralized identifiers, as I said, for that. And then the schema and application layer that runs on top of this network of decentralized data and decentralized identifiers. The colors here are left over from the side meeting that we gave. The piece that we're most interested in bringing to the IETF is the stuff in green, which is the repository structure and the sync protocol for those repositories. And then finally, I have this graphic from a paper that we wrote with the help of Martin Kleppman that is published and available on arXiv. The link will be at the bottom of the next slide. And there's a few things that have changed in here. This is about 1.5 years old, this diagram, but largely the broad strokes thrust of it is correct. This kind of gives a sense for the data flow throughout the network. So on the left-hand side, we have these personal data servers that are hosting the repositories. Those flow into these services that we call relays. They're essentially aggregators for repositories. They create a global fire hose on the other side that you can get updates from throughout the entire network. These let you rebroadcast the repositories. It gives downstream servers the option to not go crawl around and try to find all of these repositories, but they can get one unified stream for everything that they're interested in. Those flow into API servers that construct these global social views, feed generators that provide users with algorithms, moderation services, etc. And on the other side, those global views flow back into the users of the app. Sweet, and I think that's my last slide, so I'll leave it there. And if there's any questions.
Questions? So I have one that comes up. I should put myself in the queue. Hang on, just so it shows up. Where am I? Yeah. I mean, it shows up online all the time, which is you map bidirectionally from these IDs to DNS names, and yet, you know, in the world of the deployed application, something like 90% of the people have chosen their names under the same domain, which is the one of the people running the service. What are your thoughts about? I know you can, you know, if you happen to own as a person your own DNS domain, and you have sufficient technical clue to work with your naming supplier to provide the appropriate stuff, you can use your own domain. Do you see a better sort of like distributed way to get social network identities that that, you know, don't require the user to be quite so clueful, and on the other hand, don't wind up with this degree of administrative centralization of the naming.
Yeah, totally. So I think probably the best way towards that is having sort of community run groups of handles. And we've seen some people doing that. Actually, a group of Taylor Swift fans has Swifties.social, and a lot of users that don't have any technical expertise but really like Taylor Swift have their handle.swifties.social because somebody set up that community handle. So I do think that that's sort of a way to get more diversity in the domain names that people are using. Is basically technically sophisticated users run a handle directory for users that might not know how to use DNS. I also do think DNS is getting more and more approachable for users, and it's cool to have your own handle. So we've seen users that otherwise wouldn't maybe engage with DNS figuring out how to use it so that they can have a nice handle that doesn't end in bluesky.social. So yeah, and then of course the other thing is that even users that have no idea about DNS are now set up with DNS handles. It might end in bsky.social, but they're at least being exposed to like kind of the concept of these namespaces.
One more quick one.
Sure.
Certs, how do those map in? Or you don't make any use of certs?
Yeah, we don't use certs. Yeah.
So accountability is still a problem?
Well, actually, sorry, what do you mean?
The users on bluesky.social, do they obtain certificates from a particular certificate authority?
Oh, no. So there's actually two ways to map your DNS handle. You can do it through DNS or you can do it through HTTPS. So they resolve their handle through HTTPS. So I guess they
But if you go through
grabbing a
HTTPS,
cert
you're
over
stuck
HTTPS.
with the existing CA hierarchy.
Right.
Right. So that,
Yep.
there's the link is this. If we ever need accountability in the social networking system, which is, I think, an interesting political question,
Mhm.
I think you're going to have to face that problem.
Yep.
Which
Yep.
is whether the certs have anything to do with the identities that are actually used for posting.
Yep.
Thanks. You put yourself in the queue. Was that for a question or for your next talk? Or in order to talk? Please, go ahead.
Okay. Thank you. Thank you for your presentation. Actually, I'm perfectly beginner of your system, and I don't know your system at all. I'm sorry. So maybe my question is stupid, but do you have any thought or possibility to implement this system in ICN?
No, we don't have any plans for that. We implement this, it's application layer. It's not in the networking layer. It could definitely benefit from networking layer constructs and protocols. But no, all of our plans right now are at the application layer.
But actually, recently many of ICN community have been working on top of the overlay network. So even if your implementation is a higher layer or application layer, so because I thought that something like a group-based communication or storage and so on. So it's really good affinity with ICN, I thought.
Mhm.
So, and even though you said it's not a network layer, but application layer. So as I said, you can do it with a overlay network with ICN. So maybe technically,
Okay.
this is just technically, it's possible or maybe advantageous, but this is just a technical part. Maybe you have a lot of existing implementation. I understand it's really heavy to change everything to the ICN protocol, but as a potential activity, I saw that, for example, you said something about the DNS related stuff, and maybe ICN helps a lot. So that's why I'm asking this one, but it's just a technical question. So
Yeah,
well, that's all.
yeah,
Thank you.
definitely something to look into. Thank you.
Mohammed.
Mohamed from Université d'Abidjan. Thank you for your presentation. I have noticed two very nice things to me in your presentation. First, you co-authored the paper with Martin Kleppmann.
Mhm.
Oh, what is the relationship between you two?
He's an advisor for the company.
Okay, I used to say to my students that this is the grand sheikh of the distributed system community. He's a guy that has the right didactic
Yeah.
of the topic, as far as I know. Second,
He has been here to present some other work before.
sorry?
So Martin has been here in ICNRG to present some other work before. So
Okay,
we
okay.
work with
So
him.
I will be very happy to be in touch with him when you're back.
Hmm.
You will give him the news from Madrid. The second point, I was just trying to create my Blue Sky profile. I did not hear about this news social network, although I'm very, very active on the social networks. I have many profiles and I have advised many students on the topic.
Hmm.
But I see that there is a limit on the size of the identifiers, 18 characters. My usual ID is 19, it seems. I'm just discovering it. So there is one, the last character, the I can't type it. So maybe you can
Yeah,
request.
it's not a hard technical limit. That was just to
Okay,
prevent
so
abuse
add
from
one
users.
for me so that I can keep the same ID
Yeah.
I have on YouTube, on Threads, on TikTok,
Yeah.
on TikTok and so. And also, it seems we have some internationalization problem. We can use Latin alphabet and Arabic alphabet because when I had the constraint, I was trying to reveal myself for the last character in Arabic, but both are not accepted. So that's
Yeah.
just,
Well, thank you.
some
Put
feedback-
in a
some
bug
feedback.
report for that. We're always trying to work on our
So please leave me
internationalization.
your email.
Hmm?
You leave me your email.
Sure. Yeah.
For further
I can do that.
follow-up. Thank you very much.
Yeah. Thank you.
Okay, yeah, thanks very much, Daniel, for coming today.
thanks,
So the reason we invited Daniel was that, of course, we are aware that there are conceptual similarities. Doesn't mean that it's native ICN system, but it's just interesting to learn. So what are the say requirements that the Blue Skies team saw, and so what design decisions were done based on that. So in ICN, of course, there have been similar, prototype applications that have been developed in research. But okay, this is a system that works on global scale, and of course has also needs initial fast deployment. So there are different requirements, different goals partially, but it's still interesting to compare, and I hope both sides can learn something from it. So thanks again for coming.
Yeah, thank you.
So we now just have a very brief update on the chunking draft from Hitoshi-san. Oh, come up, come. This doesn't need any slides. That's why you're
Right.
not seeing anything.
Right. So there is no slide for because this is just a update. I'd like to inform that our chunking draft, which is research group draft, is almost ready for last call. So please check the chunking draft, and if there is some comment, editorial, technical, any kind of comment, please send a mail to the mailing list. And if everything is happy for all of you, then we may ask the chairs to start the research group last call, maybe before, just or within next IRTF ICNRG meeting. Well, that's all.
Great. There is a new version posted. It showed up what day,
Yep.
yesterday or the day before. Small changes, right?
Yeah, just we need to update some IANA registration
stuff,
IANA
right.
stuff. Yeah.
Okay, great. Thank you, Toshi-san. Mailing list, the
Yeah.
ICNRG mailing list. That's actually our official communication channel, as it is for most IETF and IRTF work. Because that's archived, and yes, we make decisions on the mailing list. We don't make decisions live in meetings. So thank you for asking. Okay. So here's our wrap up. We desperately need people to look at the current drafts. We have not gotten the kind of review that we need to move these things forward in an expeditious way. I'd like to thank the people who have put in reviews of our current work, but we need more participation from the broader community so that we can see what has real interest and legs to bother taking the time to move them forward towards RFCs. And the two that are pending are Flick, which has been around, as you know, for a very long time, went through last call, got some comments, sufficient ones that we really couldn't go forward from last call, but we really need more eyes on this so that we don't continue to iterate on it. So please, 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 please take a look at Flick. I'm one of the co-authors, but Mark and I will go and respin it, and we'll try to issue a second last call in the next couple of months. The second one is an in-progress draft that's been adopted by the research group on reflexive forwarding. We have a couple of technical issues that are noted in the draft that we asked for feedback from specifically, and we haven't gotten the kind of feedback in the depth that we need. We'd really like to move that forward, and I know Hitoshi-san in particular would like these nailed down with specific technical decisions on the couple of points that were open. And then we can move that forward, and hopefully that will wind up closer to last call, perhaps around the time frame of the Montreal meeting. As Hitoshi-san mentioned, we'd like some indication from folks whether they think the chunking draft is done and ready for last call. So I'll be putting out a message on the mailing list to ask people if anyone objects to that. If I don't hear objections to that in the next couple of weeks, we will in fact send the chunking draft to last call for the research group. And then lastly, hopefully, we'll find somebody to replace you by then. We are planning to meet again in Montreal in person. So please start thinking about recent ICN research that's either been published in recent venues or is in progress, which is even better, that you'd like to present in Montreal. I have a hand up from Marie-Josée. I won't make you put yourself in the queue. I'll let you just come up.
Yeah, this is the message from the local girl. Montreal, the IETF starts on November 1st. But if you haven't bought your tickets yet, make sure to be in Montreal for Halloween. It's absolutely cool. Streets are closed. There's people in costumes everywhere. I think it's the coolest. We don't have American Thanksgiving. We have Halloween. And I think it's like the celebration of fall, and it's just fantastic. So if you don't have your tickets, plan to arrive on the 30th.
Thank you. Going once, going twice. Anyone have anything else to say? We finished on time. This is really good. And enjoy the rest of what's left of the IETF. And thank you for staying on and being here on a Friday. Bye.
Thank you.
It was really good. I think people really liked it.